Hello everyone, that was a short preview of our game, The Maze Runner. I am Vishwa Desai, and I'll be explaining you a little bit about the level 1 maze that we have developed during the first sprint. Basically, we have created a new maze from scratch down. Now, I'm developing a simple maze from a mesh that is a surface. I divide the mesh into subdivisions. The higher the complexity of the maze that we require, the more subdivisions we have. Currently I'm dividing a maze into a 12 by 12 sector subdivision. Now I go into face edit mode. Basically what face edit mode does is allows me to edit the various features and the dimensions of each and every face in the maze. So I want to erect a basic maze that has inner walls, outer walls, and the complexity of level 1. We have divided our game into 4 level of complexities. At the end of each level, the user will be given a gumball based on the number of coins that he collects. So here I'm creating a basic maze. That is level 1, so yeah, it's pretty easy. Now I go into the 3D mode, and here I erect the walls of the maze. There we go. Yeah. So now I want to apply a texture to the maze so that it looks like a real life maze. So I'm creating a new material here with the texture of grass. So basically I convert my maze into a UV object, smart UV object, then apply a maze material with the texture of green grass. And there I'm editing it. That's the second view, that's the UV edit view. Now I want to apply the grass texture to the multiple phases of the maze. So the granularity of the image that I want to keep is pretty small, so that the texture is applied uniformly to all the phases in the maze. So that's why I'm extending the maze. Yeah, so that's us in 3D view. Yeah, so that's pretty much it. That's a level 1 maze. That's the inner view. You can view it from all the sides. That's everything. Yeah, sure. Thank you.
Hello, I'm Juveria, and this is one of my Blender experiments for creating a coin in 3D. This coin was created from a cylindrical mesh available in the Blender, and this is how it looks like. It was resized to look like a coin. Now, in order to give it the look and feel of a real coin, I'm going to first convert it into a UV project and apply texture on it. So first, I'm converting it to a smart UV project. And then in order to apply texture on it, we have to import the texture that is to be applied on the coin. So here I import the texture that I'm going to apply on the coin, and then edit the phases of the coin to match the image of the texture that was just imported. And this is how texture is applied to the coin. Now in order to apply animation to the coin, I'm going to give a location rotation scale at the time frame 0, and then give another value at the end of the time frame. And now when I move from the time frame from 0 to the end, the animation will be applied to the coin. So when we on the camera view and view the coin, then we can see that the animation that we just applied, we can view that on the coin. And this can be rendered as an image, or it can be rendered as a video. And we will be using this in our game, wherein the user will be collecting coins as he goes ahead in the game. So this is how it looks like.
Hello all, myself Kunal. I have implemented the trial scenes in JMonkey with first person view, which includes sky, terrain, mountains with different textures. So the basic scene would look like this. I had used the rigid body control class to streak the scene in landscape mode, so the entire body is restricted to a particular scene. Bullet abstract class and physics character class has been used for a first person model. Several actions listeners has been used to detect the action of a particular user. For example, if he tries to move forward or backward, then he can make use of the keys like W and S. If he want to move side to side, then he can make use of D and A. If the model wants to bounce on a surface, then he can make use of space. So it's basically like this. This can be extended for a gumball. So gumball will be bouncing in future. Now we will try to see what would happen if a model try to surpass the surface. So it will basically mount the surface. But if there is a big object in the middle, then there would be a collision detection and the object won't be able to surpass it. So these are the basic functionalities. Apart from that, audio node is used. So music is continuously playing in the background. These are the basic functionalities which has been implemented for the trial version that can be extended for Sprint 2 Gumball project. Thank you.
Hi, this is Rutvik, and I've implemented a couple of things in this project. We have made an object that is of a human body in Blender and exported it in JMonkey using Ogre XML. I have implemented the third person perspective of the model inside the scene. We have implemented it through the chase camera that follows the changes in the perspective on pressing up, down, left, and right keys of the keyboard. This has been done by placing event listeners on any key presses on the keyboard. I've also implemented a timer as it is a time bound game. We have implemented a timer that is of 3 minutes, and this timer expire once the timer expires, the scene is disconnected from the root node, and hence the game is over.
Hi all, this is Shilpa and I will throw some light on the task board and burn down chart of Sprint 1 for our team. This is the task board for Sprint 1. The total duration for Sprint 1 is 200 hours with 4 weeks in it. In this, each member has to spend at least 10 hours per week. These are our backlog items with the task in each backlog item and the task owner for a particular task. This is how our burn down chart is. The blue line here shows the idle burn down and the red shows what was the actual burn down. This was week 1, the week 2, week 3 and the week 4. In week 3 we have a little bit diversion from the idle burn down because our team was stuck with implementation of sound and character in JMonkey. We have used the Canvanize and Sprint 1 to track the tasks throughout the Sprint 1. Thanks.